Hello everyone, my name is Amrita Vishnuri. I'm working in the Department of Chemical Engineering at the University of Alcala as an MSc Fellow. My work here is on development of a novel microbial desalination cell that will treat ternary wastewater and will generate some valuable byproducts. As you might know, ternary wastewater contains high load of organic matter, hexavalent chromium, and salts that is generated at different stages of leather tanning process. Therefore, it is very important and it is necessary to give a quality treatment to this wastewater before discharging it into freshwater bodies. Although there are some existing technologies available to give proper treatment to this wastewater, but these treatment technologies are highly energy intensive and is not cost effective. By contrast, we are here trying to develop a novel microbial desalination cell that can give a similar kind of treatment to this wastewater along with generation of valuable byproducts. So I want to show you the system directly in the laboratory so that you will understand more easily the working mechanism of the system. So let's go to the laboratory and have a look of the experiments which I am currently doing.
Guys, now I'm in the laboratory at the Chemical Engineering Department at the University of Alcala. So I want to show you my experimental setup and my reactor design and working mechanism. So before going deep into the experiments, I want to show you a little bit the laboratory. It's a big laboratory in which I'm working on. There are different experiments currently going on. We have different instruments for sample measurement. So I have to bit focus. Okay, so here is my working space. So you can see this is my 4-chamber microbial desalination cell which is under operation now. So the first chamber in this cell is a cathode chamber, followed by chamber A, that is acid producing chamber, chamber B, that is base producing chamber, and an anode chamber. Cathode chamber and chamber A is separated through an anion exchange membrane. Chamber A and chamber B is separated through a bipolar membrane, and chamber B and the anode chamber is separated through a cation exchange membrane. This makes the system 4-chamber. So this entire assembly is powered through nanoelectra made potentiostat, and you can see this is the interface. Also, it is collecting data in real time. As far as the mechanism of this entire system is concerned, so initially the wastewater, the ternary wastewater, comes from this holding tank through this peristaltic pump to the cathode chamber, where the hexavalent chromium reduced to chromium 3 or chromium 0 biotypically, and at the same time the anions present in the wastewater, for example Cl- or phosphate anions, migrate from the cathode chamber to chamber A through this anion exchange membrane. After getting sufficiently treated, the wastewater comes to this holding tank, and from this holding tank it goes to the anode chamber. In anode chamber, bacteria present at the anode degrades organic matter into CO2, H plus and electrons, and at the same time the leftover cations migrate from the anode chamber to chamber B through this cation exchange membrane. Since the chamber A and the chamber B is separated through a bipolar membrane, this bipolar membrane has tendency to tear apart H2O into two parts, H plus and OH minus ions, as soon as we apply voltage from this potentiostat. So H plus ions will migrate toward the cathode chamber, but the cathode chamber and chamber A is separated through an anion exchange membrane. Hence, H plus ions cannot cross over from this anion exchange membrane to the cathode. Thus, it will trapped in the chamber A itself. Similarly, OH minus ion also cannot migrate toward the anode chamber, since the chamber B and the anode chamber is already separated through a cation exchange membrane. Thus, will be trapped in chamber B. In chamber A, we already have anions like Cl- phosphate, so they will react with H plus and will produce corresponding acids, for example HCl or H3PO4. And in chamber B, we already have some cations in the form of Na plus or NH4 plus. They will react with OH minus ions and will produce NaOH or NH4OH. So these acids and bases are collected in this acid and bases collection containers. We recirculate this collected acids and bases through these chambers continuously, so that we can get more amount of acids and bases. As far as the initial results are concerned, we are able to remove almost 100% Cr plus 6 from the ternary wastewater, or you can say simulated ternary wastewater. We have not tried real ternary wastewater yet, but we have made laboratory based synthetic wastewater and tried it. So almost 100% chromium is reduced, and almost 50% of salt material, or you can say NaCl is recovered in the form of HCl and NaOH. So this is how this entire system works. I want to show you the bacteria which I am using. I am using pure culture Geobacter sulfurudescens, which is cultured in a freshwater medium with fumarate. And you can see fumarate and acetic acid, which you can see this is nice pink color culture. I am also working in a different experiment, which is a dual chamber microbial fuel cell type system, which is also fabricated to remove hexavalent chromium in different forms. So this is the initial experiment which I have already set up, and I am also waiting for the results to come. So I hope you guys enjoyed this experiment and I could explain you properly. So if you have any question, so please keep me posted, and I want to know your views and opinions in this experiment. If you want to come in the laboratory and have a look, or you want to chat with me, you want to do some experiments with me, you are most welcome. You can find me in the Chemical Engineering Laboratory 6. I will welcome you guys with some coffee, and we'll have a little chat and we will talk science. I will learn something from you, you will learn something from me. So it will be a nice engagement.